So let me give you a short impression about COMOS in the area of basic engineering. Wherever you are doing a change inside of the plant, then the underlying documentation needs to be managed. So therefore, we'll use here a block diagram which contains more detailed information about the underlying process. Here, this is a glycol production created on simulation data for all the different cases. For example, for the design case, we imported the simulation done in Aspen. In the future, this will be also possible for GPROMs. Several standards are already included importing from Pro2, HYSYS, ProMax, etc. Based on this import, all the equipments and also the process streams has been imported and automatically connected and placed here on this document on the process flow diagram. Plus also the data which is behind of these objects and also are created through the import we've got here. So when we have done another simulation, this kind of simulation can import it. Also, in this case, we are importing for the minimum case and is seamless handed over to all the inline components to the streams automatically, and also equipments which are not part of the simulation getting their workflows like you see here, and with this the data to do a good dimensioning. Data which is inside of COMOS stays consistent wherever it is used. When we have the need of an early data sheet to get information from our pump suppliers, because it's equipment which takes some time for purchasing, we have got the different views on the information concerning temperature at the inlet, and wherever this is modified, for example from the sub-supplier, we are getting this data information back. It is directly synchronized and consistent wherever this information is presented. And when changing it back, for example, the change is everywhere consistent. COMOS, the seamless integration, the core document for the complete plant engineering and plant operation. The data we have imported on the stream is now handed over to the related pipes inside of the P&ID, so that we find now here our PFD information, can decide which should be valid in the P&ID and then accept this selection criteria, and then it's inherited to the pipe, and when we are following this also to all inline components, so that, like for example also this valve. In the basic engineering, different workflows are possible, so that for example you can also work with media data as a media list, specifying here the process data, the design data around of this media, and use this directly on the pipes by just linking here this information, getting the workflow, to the pipe again, and also to all inline components. Another role is electrification of all the consumers, where you can specify that the agitator drive needs to have a power of 8 kW, so that you can do a good dimension of the switchboard, and instruments can be edited to stabilize the process inside of this reactor vessel, just connecting it and interlocking, for example, this valve here. Big part inside of basic engineering is also the electrification So here we find behind of this drive also the electrical information. In this case here on our single line diagram. And we have got here a spare one which we like to use on our agitator drive, which we just have recently specified, and it's then only a connection of the electrical to the process information. And with this we are getting consistency between process again and in this case electrical. Plus again the workflow that here we have got the need of 8 kW, can calculate the currencies, and also this is calculated. Data consistent again. Up to information to the cabinet design. Just an example. Instrumentation wise, we have got the loop where we find sensor elements which with the technical data up to the needed I/O, which takes in this 4 to 20 milliampere signal. The signal can already used here on logical diagrams that explains the basic automation concept behind it, and give already the information that the signal high should interlock the inlet valve. An alternative to this view is a cause and effect matrix, where we have got here the causes, for example level high, and here the effect, close the valve, interlocks the valve. The workflow here is more data based. We've got here the cause of the level. If we take also the cause of the pressure high, we can just add it here, link it in an OR gate, then we have got the basic engineering information that level or pressure high should interlock this valve. So based on all this information, we are now ready to create the purchase requisition for all the different kind of equipments which needs to be purchased: vessels, pumps, heat exchanger, filters, all kind of inline components like armatures, valves, different instruments, pipes, switch gear, automation system, hardware behind it, and also the software behind it. And from here on it goes then in the detail engineering. That means all the different offers needs to be incorporated into the system, needs to be compared. Impacts from one offer needs to be synchronized with technologies out of the other offer. Typical engineering tasks. That's it.